So today we will study the plotting of curves. How to plot curves in Scilab. So there will be basically three types of curves that we know in mathematics. Namely, the first type is the Cartesian equation, which will give us the Cartesian curves. Second one will be our parametric curves, and the third one will be the polar curves. So we will study over here Cartesian, parametric and polar tracing of curves. So number one, in first one, if I want to plot, we can start with very simple plot. Okay, let's start with the plotting of y equal to x square. We want to plot y equal to x square. So how to plot y equal to x square? So for this, what we do is we write down in the notepad a small code. So first Scilab. Before that, we will just label our code. The name of the code is plot of parabola. Plot of parabola y equal to x square. So first step is getting the figure window cleared. The previous figure will be cleared before we trace the new figure. Then we will give values to x and then we will find out corresponding values of y. So I will say x equal to, let's say x equal to 0 is to 0.1. So at a distance of 0.1 from 0 to 10. Let's say these are the values of x. These are linear spaced values of x from 0 to 10 with a distance of 0.1. Then we say calculate y by the formula y equal to x square. Y equal to x square. The next step will be plot x comma y. So this is the inbuilt command, plot x comma y. This will plot our parabola x comma y. So let's run this. Before that, it will ask us to save it. So let's save this. I'll say number one, my plot y. Plot 1 parabola. Save. So I've got this curve, simple curve. I'll just dock this. So the docking is done over here. And enlarge the window size of the figure. So this is our figure. If I give negative values of x also, if I consider them, it will be minus 10 to plus 10, suppose. In that case, this is going to be a perfect parabola. This is going to be a perfect parabola. So that's how this plot command works, very simple way. If you know y as a function of x, you can give values to x and you can find out the value of y, and then you can say give the command of plot x comma y. Now once that is done, you can do some fancy settings. You can say that I want this in the green color. So single quotes, I'll say G and over here green, and I'll run this. So my curve comes in the green command, green color curve. I want it in pink, so I can say pink. Okay, the pink is not there, but yes, blue is there. Blue. Okay, for blue, I think B will be okay. Okay, that doesn't work. Let's say red. Red also doesn't work. Okay. There is some problem with the code. So red also works. You can say plot xy red red, or you can say R, or you can say blue, or you can say R and star. R and star means asterisk. You will get asterisk. If you want the green asterisk, you can give G and star. If you want a dotted one, so you can give dash. Dash like this. So these are various decorations that you can do with the plot command. You can label the x-axis and y-axis. X label. X label is the command, and then you can label it. Similarly, you can label y label, and say I am y. You can run this and say this is blue, and so x-axis and the y-axis are labeled. You can have, instead of I am X, you can write down years, and here you can write down population. If your x-axis and y-axis represents those ways, so that way you can describe what is x-axis and y-axis. You can give title to the graph. T-I-T-L-E, title is the command. Title, and you can say this is population graph. Let's say this is population graph from survey. So you have this label of this graph, title of this graph also, population graph from the survey. Population graph from the survey. So this way you can include various informations in the graph. Various informations in the graph can be included. There is a command called as comet. So instead of this, you can use the comet command. Comet x, y. Let's see what it does. Comet. So that's how it goes. Just look at it again. It gives animation to the curve. It gives animation to the curve. If you want both of them together, you can obviously have plot and comet command together. Let's say first it will do the plot and then we'll have the comet command. So first it is plotted and then the comet command is working out, right? So I'll say red and star. If you take this comet first and then the plot, first the comet works and then the plot command. So as per the sequence, you will have to make it. Right? So these are some basic informations about plotting of curve. These are just basics. Okay, save it. So this is about Cartesian curve, and now we can start with a parametric curve. How to plot a parametric curve? In Cartesian, you anyhow have y in terms of x. You give the values, and then you can do it in this manner. Okay, so now let's have a new file. In this, we'll try to plot the parametric curve. Let's say I'm plotting the parametric curves. In parametric curves, let's try to plot a cycloid. Let's try to plot a cycloid. Here, this process. Cycloid. In cycloid, the equation is generally, the equation of the cycloid is, there are 4 types of standard equations. So we'll go by standard only. X equal to a into t plus sine t and y equal to a into 1 plus cos t. T equal to minus 10 to 0.1 to 10. Let's say I'm giving these values for cycloid. Instead of minus 10 to plus 10, I can take it in terms of pi also, but let's check it with 10. These are the parametric, the values for the parameter t. Then I will specify my value of a. Let's say a value constant is 3. Then I will say calculate x. X will be a star t plus sine t, t plus sine of t. So that's it. Then we have y. Y will be equal to a star. Star means product into 1 plus cos t. So that's it. Now we say plot. Plot my command. Plot my graph with the red color. Star asterisk, and to give some added animation to it, I will say comet xy. So let's run this. Before running it, you'll have to save it. So I will say plot 2. Plot 2 is my parametric. So let's check it once again. So comment goes later on. First goes the plot. So I will just interchange the sequence. CLF is not included, that's why it is okay. CLF included now. Yeah. That's how it goes. So that's how you plot the command for code for parametric cycloid. Even you can change this value. You can give it from 0 to 2 pi. Let's say it is 2 star 2 into pi. So pi is a special character, so I will use %pi. That's how it goes. Yeah. So let's take it as 6 pi. Half circle and cycloid. Now if I change these signs over here, if I take minus sign, and here in the equation I am changing the equations. So the in between sign I am taking it as minus instead of plus. Then I get a shifted cycloid, translated cycloid. If I take opposite signs, one it is plus and the other one it will be minus, then I'll get the inverted cycloid. And similarly the other one, if the first expression for x is plus and the expression for y is minus, then it will be shifted. So you can beautifully plot and give animations to the parametric curves. Such type of parametric curves are many. You can plot asteroid with this, cycloids you have seen. You can plot cycloid with this and asteroid with this. And there are many other curves. Let's take another curve which I have already plotted. So here I have considered the equation, parametric equation to be x equal to t square and y equal to t minus t cubed by 3. Since this equation is has even powers of x, therefore this will be symmetric about y-axis. That's an extra information that you should know. Those are basics of curve tracing. So here you have x equal to t square and y equal to t. So what happens is I plot it in 2 bits. First one will be plot x comma y and the second one will be plot x comma minus y. First above one will be in red and the second plot is in green. Let me check this, run this, and I get this curve. So this is my alpha curve. Curves like this, like a fish. So this type of equations are also there, and then you can plot it using the commands. Now we'll go to the considering the polar curve. So let's consider a simple example of a polar curve. A simple example of polar curve is the cardioid, simple cardioid. Let's take that. So I'll just write down the title of the code, polar cardioid. Equation is R equal to A plus B cos theta. first thing is Scilab, clear the figure window, whatever is previously drawn should be cleared. Then we give values to theta. Theta will run from 0 to, let's say, theta equal to 0 to 0.01 up till 2 pi, 2 star percent pi, semicolon. Then I give values to A will be equal to 2 and B is also equal to 2. There are three possibilities: A equal to B, A less than B, and A greater than B. So first possibility I have considered A equal to B. In this case I will plot R equal to A plus B star cos of theta. So P-H-E-T-A theta. That's it. Now we have the inbuilt command for plotting the polar curves as polar plot. Polar plot. Theta and R. So that's my command, and save it and run it. Plot 3. Let's say plot 3 polar. See. So this is my curve that you get. So I get a cardioid, beautiful cardioid, A equal to B. Now I change the value of A. I'll say A equal to 6. Now A equal to 6 and B equal to 2. That means A is greater than B. A is greater than B is the second case, and I execute it. So this is how I get. The difference is very too much. So what I will do is take lesser distance so that you get the difference. So this is how it goes. You can magnify the things and you can get a clear picture, and you can zoom in and zoom out to check this. If your B is more, suppose my B is 7, so I get this. Okay, there is a loop inside in the curve. There is a loop in the curve. So that's how you can plot a polar curve. Here we have plotted, we plot cardioid. We can similarly plot rose curves. Petals are there, so rose curves can be similarly plotted. So I have a rose curves plotted already. So the equation is R equal to A cos of n theta, or R equal to A into a sine of n theta. Generally, here this is the equation. A, instead of 2 and 4, you can consider any other variable, any other constant number. So if you run this, I have given theta value, R value and polar plot. 3 steps, and you execute this and you have it. These are the petals, and so it is called as rose curves. So instead of 4, if I have 3, then you get this. Here I have to make changes over here. 3 petals. 5 petals. 7 petals. But if I take 4, I'll get 8 petals. Okay, so that's how it goes. We can just observe it. Instead of cos, if I take sine, it is shifting of the previous graph. Just check this. This is my graph. The pattern is here. Now the pattern will come over here. So this is it. So this is your polar plot and rose curves. You have spiral curves. Some standard curves are there. Polar curves, rose curves, cardioid, spiral curves. These are all standard curves in mathematics that can be plotted using the simple 3-step command.